Okay. Hi guys, good evening. So today we are going to cover the topics on BDF and how the enumeration works basically. And till yesterday we have covered what is the overview of the configuration in the PCI, and the configuration header type 0 and type 1 we will be also covering today. So let's start with the BDF. So BDF stands for B stands for bus, D stands for device, and F stands for the function. And so if you see this, you can see this structure. Okay, we have the root complex, and we have let's say three downstream port, let's say two downstream ports here, and then it is connected to we can say this is a switch, and then this switch is connected to a device, okay, which has two functions, function 0 and function 1. And this port is connected to another device which has function 0. So you see every device and so this is P2P. When I say this is the bridge. So every device and every bridge has in the topology they will be having a bus number, device number, and function number. So this is the way how. So this is needed because software needs to identify what are the devices, or what are the identities, or I would say devices, or the entities are existing in my topology. So it needs the mechanism to identify, right, what is there in my topology. So this is where bus, function, and device numbers comes in handy. So as mentioned earlier, a bus, there can be 255 bus in a system. On each bus we can have up to 32 devices, and each devices can support up to 8 functions. Okay, and also all the questions related to this we will be covering at the end. Also, if you have any questions at this point, please type it on the chat. At the end I will go through it and try to answer all the questions. Okay, so this is what is the meaning of the BDF. Okay, bus number, device number, function number. Okay, so BDF is assigned, how the BDF is assigned. So during the enumeration process, the device driver or the software is going to assign this bus number, device number, and function number to each device. Okay, so it's like each device should know they are living on which bus, right? If I say this device number, this is the endpoint, right? It has two functions, so it should be, system should know it. So you should know it is this device is living on which bus number. So this is the idea where we are doing the enumeration. Okay, so while doing enumeration is using the algorithm called depth first search. So depth first search, I will try to explain how it works. So depth first search is like, first it comes to the left, then it comes to here, then again it comes to left, and then it comes to here, and then it finds nothing, then it goes back here. Okay, and then it goes here, and then here, then it finds nothing, then goes back, and then it goes here, and then it will go here. Okay, and then it will go to this bridge. Okay, and then again it goes to here, then left of it finds what, then here, again goes back, then here, again goes here, and then here. Okay, and then again goes up, and again goes up here, and then it goes here. Okay, that's how it works. So I will, while the enumeration, I'm going to explain it, how the bus numbers are getting assigned. Okay, depth first search, multifunction devices are there. Multifunctions means the device having multiple devices. Identification of device is simple, device 0. Okay, multi-functions are implemented parallelly. So parallelly means once it's coming to read the type 0 and type 1 header. Okay, as mentioned earlier, we have type 0 and type 1 header in each function. So it is coming to read this first, to read this while doing the enumeration. Okay, so before that I just want to explain you this before I jump other slides. So this is, I explained you yesterday also, this is the PCI configuration register space. Okay, we have two types of PCI configuration register space. It is called type 0 and type 1. This is present in every function. Okay, for each function there is either this will be a type 0 or it will be a type 1. So how do we identify what is type 0 and type 1? If it is type 0, if it is an endpoint, right? If it is not an endpoint, as in if the function is like bridge, okay, or switch. So it is that is going to be type 0. Okay, and previously also I explained that there are some of the parameters which is like important one, capability pointer. I explained you guys also, where like if you read this, it will tell you where is the next capability implemented in this full configuration register space. Okay, and we have bar 0, bar 1. So this we will be probably covering how the address mapping is done in the system memory, that I will be explaining probably tomorrow. And today again we have the header type. Okay, this is header type. Now the header type is very important during the enumeration process. Okay, listen it carefully. So this is a 8-bit field. First 7-bit indicates whether it will be type 0 or type 1. Okay, if you read the header type, if you see the first 7-bit is 0, then that means it is type 0, and this type 0 means this will be the endpoint, right? The function is endpoint. And if it is type 1, it is a bridge. Okay, it is not the endpoint. The function is a bridge. Okay, and the last bit, it is a 8-bit field, right? So last bit, if it is 0, then the device has only one function. But if it is 1, if the last bit is 1, then it means this function is that there are more than one function in the device. Okay, it's a multi-function device. So hope this is clear. And okay, let's go back to the what is the okay, this is kind of I have explained already. So in the PCIe conf, we are having the 62, every function is having the 256 byte of configuration register space. Okay, and this is per function. Okay, but when we moved from PCIe to PCI Express, okay, this space 256 byte was increased to 4096 byte. Okay, which is 4 KB of address space. Okay, so each function in PCI has 4 KB of address configuration address space. Okay. So okay, here we are trying. Here we are saying that we have 4 KB of configuration space per PCI Express function. So see, I already mentioned this PCI config header and PCI device specific and new capability register sets. These are like 256, right? We are having 256 D word, which were like coming from the PCI conf. Okay, offset is 100, that means 256. Okay, and the remaining 960 D words kind of the from 256 byte we move to 104096 byte, which means like 1024 D words. So additional 960 D words address space was added in the PCI Express. Okay, so to access this PCI PCI registers as well as PCI extended configuration registers, we are having two methods to do that. First is like yesterday I explained, right? We have address port and data port, and we were using 2 cycles to read the to read or write the config register. So that is one mechanism. Another mechanism is like what we have done in the PCI is like all this address space configuration address space, we have mapped that into the memory space, into the memory register. Okay, system memory. So what happens is like whenever you want to read or write, instead of reading registers directly from the function, you can read it from the memory, so that it will be done only, it will require only one cycle to do it. So that's the main reason why we have mapped this set of the registers into the memory now. Okay, so already mentioned, like each function is 4 KB, each function has 4 KB of address space. So this is important point, so please remember this. Okay, so I think it is clear. So so in this set, first 16 D word is the type 0, it is the type 0 or type 1, right? I just mentioned you, right? The first 16 D word, 64 byte 16 D word is going to be of type 0 or it's going to be type 1. It is fixed, and it is even continuing today in Gen 6 also. This thing is not going to change. Okay, so this was there in PCI and PCI Express also. This thing is going to be okay. This 64 D word still exists today. Just give me a minute. Okay, I mentioned there are two ways to do that, right? PCI legacy configuration mechanism, which I discussed yesterday. We have address port and data port, and there I explained right how things are working. If you want to do a read or write, see if processor wants to do the read and write, processor is coming. Let's say it wants to do a read. So what it is doing, it is coming and writing the address in the data port, and it is doing the write to the data port, and then your RC is kind of generating a transaction with this IO, with this address, with the value that processor has written in the address port and the data port, and then it is generating the config transaction. So it is taking 2 cycles, right? So but this is one way, and enhanced configuration mechanism where we are using memory mapped accesses. So I just explained just a while ago that we are mapping this configuration space of 4 KB into the system memory. Okay, I explained. Okay, what is this? This is the enumeration. Okay, so this is single host system and this is the multi. Okay, so single host system means we are having only one processor. Okay, and processor. After that, we have a root complex, and we have the devices hooked to the root complex. Okay, we have six. Okay. So yes, so just want to let you know that what is primary bus, secondary bus, and subordinate bus here. So just for the reference, the primary bus is the number on which this bridge is living just above it. Okay, this is the primary bus. Secondary bus is the number on which below this bridge. Okay, this is 3, and subordinate bus is the number below this bridge. What is the maximum bus number below this bridge? Let's say for if I see for this bridge, primary is 0, secondary is 1, and subordinate bus number is the maximum bus number on this bridge which is living. So maximum bus number you see is 4 here. Okay, if I see for this bridge, the maximum bus number is 4 here. Again, if I see for this bridge, the maximum bus number living here is 4. Okay, from this bridge point of view. Similarly, from here, if I see here, the maximum bus number from this bridge point of view is 9. So it is a subordinate bus number is 9, and secondary bus number is 5, and primary bus number is 0 here. Okay, similarly, I hope this is clear. So if I see from this bridge point of view, the 9 is the maximum which it has. Okay, primary is 5, secondary is 6, right? This bridge number bus is written. Okay, so this is a single host system or system root system where we have only one processor. In multi root system, we have more than one root complexes. Okay, and we have inter-processor communication going on. Okay, so this is nothing but just 2 root complexes are here. Okay, so in modern system like in server and all, we are using this types of configuration. Okay, before that, just one thing I want to highlight. So this thing I already explained you, right? So 64 byte PCI header config space. In type 1, you see the D word number 6, byte 1, byte 2, byte 3. The first byte represents the primary bus number. Okay, and this second byte represents the I will be sending the recordings later. Okay, so please don't request for recording and all. So first this is the first byte. This is the primary bus number, secondary bus number, and subordinate bus number. Okay, these 3 are the important things. Please keep this thing. Please keep these 3 things, this 3 register and the header type in mind. When I will be explaining, I'm going to explain the enumeration. So these 4 parameters are important to understand it. I already explained what is header type. If the first 7 bit are 0, it is type 0. That means your function is endpoint. And if the header type first 7 bits are 1, let's say if you read it, if you get the value 1, that means it is type 1. The function is not the endpoint, it is a bridge. Okay, this is important. Okay. This is already explained. Single root, multi root. Okay. Okay, so this is the same thing I'm trying to explain. If it is a type 0, okay, the target bus number matches the secondary. Okay, whenever if you see it is target, it's 0 type 0, the target bus number matches the bridge's secondary bus number, which is obvious. And type 1 it will not match. So we can see here. See here for this bridge, if this is if the function is the endpoint, this secondary and subordinate bus number is meeting, right? Here also see if this is the endpoint, the secondary bus number and subordinate bus number is same. Here also same, right? Here also same, here also same. So this is what it's trying to say. Okay. Now, software is sending configuration read and configuration write. Okay. So how do this your devices, I mean functions, which can be like endpoint or it can be bridges. So how it is going to identify which type of transaction it is, whether it's a config type 0 config, it is type 0 configuration read or write, or type 1 configuration read or write. So we have, so packet structure, we will be covering this more in when we go to the transaction layer in detail. But this is the packet format, how we are sending. So we have format and type. So just for now, just remember that format and type is used to, I mean, it is the format and type is the parameter or attribute which decides what kind of TLP is being sent or received. Okay, the core can decode this and figure it out. Okay, if it is type, it is mem TLP or configuration TLP or completion TLP. Okay, so if this bit is 0 in the type, if last bit is 0, for you will see that for configuration read format is going to be 00, this is going to be 00. Okay, and if last bit is 0, okay, if last bit is 0, that means type 0. For configuration right, this is 010. Okay, so this is one thing. And similarly for the configuration, you don't have type 1, you haven't covered for type 1. Okay. Similarly, for type 1, okay, let me go through this spec. Explain. This is type 0. Okay, and this is type 1. If the last bit is in the format remains the same for the configuration read. If this is bit is 1, then this is type 1, and this is right. If this is 1, that means this is type 1. So that's how that's how this bridges. And if let's say if the configuration is targeted to some particular bridge, okay, how will it identify whether this transaction is for me or not? Okay, if it is 1, okay, they know, okay, this transaction is meant for some bridge, but how do they know it is meant for me only? So for that we have bus number, device number, and function number, which I just discussed. This is the identity by which they know that what is my identity. Let's say it says my identity, it says some bridge number, some bridge has their BDF as 100, and this transaction, this BDF, this byte, this full value comes out to be 100, then it knows, okay, this transaction is meant for me. Okay, so I'm just going to explain, I will be explaining in a bit what is enumeration here, what is how the enumeration is done. It's done. Is this okay? Okay, let's just take the example. This is telling how the traffic is flowing. Okay, let's say config read is there and it is targeted to this device. Okay, bus 4, device 0, function 0. Okay, so how it will know that let's assume that enumeration is already done, for example, and how it will know that it is this packet has to go here. Okay, so this packet goes over here and over here. Okay, now this is type 1, right? Now the transaction we are sending is type 0, right? So but for this the header type is always 1, right? So it knows that this transaction is not meant for me. so it sends below. Okay, then it comes to this bridge, right? Again, this the type I just showed you, right? The type is 0. Okay, in the format and type I showed you that bit, right? Whether it is a type 0 or type 1. So since the transaction is meant for the endpoint, the type that in type the last bit is going to be 0 in this format and type attribute. In type the last bit is going to be 0, right? So again, this knows that this transaction is not meant for me. It goes for to both the bridges here, this bridge and this bridge. But again, this is the bridge, so they know this transaction is not meant for me. So either it can go to bus 3 or bus 4, but here we have the bus 4 device 0 and function 0, right? So the bus 4 lives below this, right? Not below this. Okay, so the transaction is routed through this path and it comes to the endpoint. So this is how it works. Okay. PCIe enumeration. Okay. This I'll just explain in a bit. Yeah. So okay. So I'm going to explain this. Okay, this and the final result which you will get after the enumeration will be this. Okay, this is the final result which you will get. Okay, so again going to explain you. So as explained, a depth this enumeration happens via depth first search. This is an algorithm. You can Google it. You will find it how the depth search works. Okay, it is because you would have learned it. So just Google it. So, okay, in the root complex, the bus number is always 0 for sure. Okay, this is the bus number is 0 and the processor or software knows this. Okay, so this bus number is 0 and in the host, this is also a bridge. So for this, okay, now this is a PCI bridge, right? So I just mentioned, I'll just refer once more. Every bridge is of type 1, right? Type 1 means this they always have this header, right? This corresponds to this header, and if this is type 1, this header type is the first 7-bit is going to be 1. Okay, this is for sure. And the bridges always have 3 fields, which is subordinate, secondary and primary. And you see we don't have such fields in the in this type 0 because type 0 is the endpoint. There is no bus living below that. Okay, so I hope this is clear. So let's start from the host PCI bridge. This is a bridge. So it has secondary bus register, primary bus register, and subordinate bus register. Okay, right in the start, what it is going to configuration software is going to set the primary bus number. Primary bus number will not be. I think that will be reserved for the PCI host bridge. Okay, secondary bus number is the bus 0 and the subordinate bus number is 255. Okay, just hear me out till 255 is the maximum bus number which can be assigned. Later we will see that this bus subordinate bus number is overridden. Okay, so right in the start, the secondary the function, this host PCI bridge, it will have the primary bus number as reserved, secondary bus number as 0, and subordinate bus number as 255. So okay, and so now the depth first search will go to to the bridge A. We are calling this at bridge A. Now what the configuration software is coming is coming and reading the vendor ID of this virtual bridge kind of bridge, and it sees that we have the valid vendor ID. Okay, and it also reads the header type. If it when it reads header type, it gets 1, so it knows that this is a bridge. And since it is a bridge, now it knows it has secondary bus register, primary bus register, and subordinate bus register. So the software is going to write primary bus number, secondary bus number, and subordinate bus number in those registers. So the primary bus number will be bus 0, secondary bus number will be bus 1, and subordinate bus number will be 255. Okay. Now it comes to this bridge. Okay. Here also what it is going to do, it is going to read vendor ID, okay, and the header type. And since it is a bridge, so since vendor ID and header type, and it finds that the vendor type is the valid one, okay, and header type is 1. So again, what it is going to do, it is going to, the configuration software is going to write in the subordinate register, primary bus register and secondary bus register, and the values of the primary bus register will be 1, secondary bus register will be 2, and subordinate bus register will be 255. Okay, since it is depth first search, it comes over here. Okay, it comes to this point, and now this is also a bridge, right? So again, the configuration software is going to read the vendor ID and the header type, and it finds that okay, it is a valid vendor ID and header type is 1, so it knows that it is bridge. Again, it is going to do some writes, updating the all three kinds of registers: subordinate register, primary register, and secondary bus register. So for this, the primary bus register will be updated with 2, secondary bus register will be updated with 3, and subordinate bus number will be updated with 255. Okay. Now configuration software comes over here. Okay. Now this is the endpoint, right? It is going to read, okay, vendor ID, okay, we have valid vendor ID, and header type, what it is going to read is, it in this case it will be 0, so it knows, okay, this is the endpoint. Okay. And I mentioned like last bit in the header, bit number 7, says whether it is a multifunction device or there is only single function device. So if it is 1, that means multifunction device, so it is going to read for function 1 also. Okay. And it comes to know, okay, this is the endpoint, and then it does nothing. Okay, it goes back to this. Okay, and now at this point, when it comes to bridge D, okay, now it knows what is the maximum bus number on this bridge. It is 3, right? Below this 3, so it is going to update the subordinate bus number register from 255 to 3. Okay, and again it comes to this side. Okay, depth first search, it comes here, virtual P2P. Again, it knows that it is the bridge. It reads the configuration software is going to read the vendor ID and header type, and decides that, finds out that okay, it is a bridge. Okay, then again it is going to update the primary bus register, secondary bus register, and subordinate bus register. So the primary bus register will be updated with the value of 2, secondary will be 4, and subordinate bus number register will be updated with the value of 255. Okay, now it comes here and reads the header, reads the vendor ID and header type for this device, and it finds out that this is the endpoint, so it does nothing. It goes back to the bridge E. Okay, and then it is going to update the subordinate bus number register with value of 4. Okay, and since this is a bus, okay, in the PCIe system, here we can have multiple devices, right? This is device 1. Okay, there is, it tries to read for, scans for device 2, device 3. It's not there. Okay, so it returns back to this point, okay, to the bridge C, and here also it is going to update the here also it is going to update the subordinate bus number register with the previously we assigned to 55, if you remember. Now it will be updated with the bus number value 4. Okay, now it goes back over here A. Okay, if you remember, here also we assigned the subordinate bus number with the value of 255. Okay, now it is going to update that value to 4. Okay, the maximum bus number which is living below this bridge. Okay, now it goes over here. Okay, now it comes to B, and it's trying to do same thing what we discussed for this bridge A. I'm just going to say how it is going to happen. So now here also software is coming and is reading the vendor ID and header type. Okay, and finds out that, oh, this is the bridge, so it is going to update the primary bus register, secondary bus register, and subordinate bus register. The primary bus register value will be 0, secondary will be 5, and subordinate will be 255. Okay. Now it comes to bus number, comes below to this. Okay. And because there is no other functions in this, we are assuming there is only function 0. If there are more functions, then it will continue doing for them also. Now it comes to here bus number 5. Okay. Here this is also a bridge, right? Software reads the vendor ID as well as the header type and finds that this is a bridge. Okay, so what it's going to do is going to update its primary bus number, secondary bus number, and subordinate bus number. And the primary bus number will be 5, subordinate bus number will be 6. Secondary bus number will be 6, and subordinate bus number will be 255. Okay. Now it comes to its depth first search. It comes here. Okay. This is also a bridge, and so software will read the vendor ID, right, and header type, and finds that okay, this is a bridge. Again, it is going to do some configuration rights, and it's going to update the subordinate bus number, primary bus number, and secondary bus number. So for this, the primary bus number will be 6, secondary will be next after 6, it will be 7, and subordinate will be 255. And then it comes below this. Okay, it says the okay, it starts reads the vendor ID and the header type and sees that okay, this is my function Z. This function is an endpoint. Okay, so it does nothing. It goes back, and for the bridge G, it again initiates the config write and updates the configuration. So it updates this subordinate bus number with value of 7. Okay. Now it goes here. It will go to the H, and for H the same process is repeated. Okay. Here again it says that it's a bridge. Okay. So since finds the valid vendor ID and header type, sees that header type is 1. So again, it's going to do write to the secondary, primary bus register, secondary bus register, and subordinate bus register. So in this case, the primary will be 6. Okay. Secondary will be 7. Secondary will be 8 because 7 is already done. 7 is already assigned, right? So after 7, it will be 8, and subordinate is going to be 2. Okay. It comes below here. Okay. This is PCI Express bridge. Okay. So this is PCI Express bridge. So for this also it sees that okay, this is it's a bridge. So again the vendor ID is valid and the header type is 1. So again what it is going to assign it, the primary bus number will be, the configuration software will update the primary bus number with the value of 8, secondary with the value of 9, and subordinate with the value of 255. Okay. And after that it comes over here, and it says that this bridge has 3 devices, device 1, device 2, device 3, and kind of these are this is the bus, but these are the endpoint. Okay, this is the endpoint. So it goes back, does nothing, goes back from here to J, bridge J, and then in J it is going to update the subordinate register with the value of 9. Okay, and then it goes to I. Okay. In this I also it is going to read the vendor ID and the header type and sees as configuration software comes to know that okay, this is a bridge. So it has to update the primary bus register, secondary bus register, and configuration bus register. Okay. So the primary bus register is updated with the value of 6, secondary is updated with the value of 10, and subordinate is updated with the value of 255. Okay. It comes below. Okay. And here it says okay, this is the device, this is function 0, then but on device 0 function 0, but this is the endpoint. Okay, so does nothing, goes back and updates the subordinate bus number with the value of 10. Okay, and then what it will do, it will go back here, right? F. So here also there's no more devices on this bus, no. So it scans, it found nothing is there, then it goes back. Okay, and then it's going to update the bus subordinate number of this bridge F with the maximum value of, what is the maximum value of bus living below this? So maximum value we saw, right? It was 10 just before. So it's going to update the bus subordinate register number with the value of 10. Again, it goes here. Okay. Now here initially, you know, the value of bus subordinate number was 255. Now it is going to update that value to 10. Okay, and it goes back here, and then in the PCI host bridge, it is going to update. Initially it was 255. Now what is the maximum value that is living below this bridge? It is 10. So it is going to update the subordinate bus number register with value of 10. So this is the full flow, how the enumeration works. I think if you would have followed, you would have got the fair idea. But I recommend you to go ahead and read this enumeration, how this is done in Mindshare Gen 3. It is explained what I have explained. It is explained again. Just try to read it. You will get the more insight on how the enumeration is being done in the PCI system. Okay. So this is done. Okay, in multi-root system, it is nothing. So we saw that, right? So this is what we saw, right? So you see, okay, it is bus 9. Okay, this is the difference. So I just want to show you what final number was. So this is this is what we're discussing. We have this example, right? This example. So see, okay, no, this is the one which I explained. We don't have the one which is finally done. Yeah, this is the one. If you see, after the enumeration, the process that I explained, see what is the value of primary, secondary, subordinate. Okay, primary is 0, secondary is 1, subordinate is maximum bus number, which was living here 4. Okay, so for this also 4, for this 3, for this 4, for this the maximum. So secondary is there is no primary for this. It is a host bridge. Then there is no, I think there is no value for the primary. Okay, the secondary is kind of 0, living below it, and subordinate bus number will be 9, right, at the end. So this is the maximum, that this is the what I explained right just now. So do we have to cover this? Okay, I think let's cover this tomorrow. Okay. Let's cover this tomorrow. Okay, I think it's not for today. Okay, guys, I'm done with the explanation. I will be covering the address space and translation tomorrow, address space and transaction routing tomorrow, and how this addresses are mapped into system memory. Okay, so okay, we are open for the questions now. Give me 1 minute. What is unmute? Okay, guys, go ahead.
Yeah, hi.
Okay, hi. Yeah.
Yeah, I had a doubt like, we are using header files, right? As you said.
Not header files, configuration header type 0 and type 1.
Okay, configuration type 0 and type 1 we are using. So inside that, if you see the packet of any TLP, so we had header file is there, right? That is around 3 double word or 4 double word will be there. Yeah. So in this, but you're telling about 1024 double word.
Okay, can you repeat your question?
Normally, if you see a TLP packet, we are having header file as 3 double word or 4 double word.
Right.
Yeah, but you're talking about like 1024 double words of type 0 and type 1. So can you
Yeah,
tell me?
but that is 1024 D word is like the memory, this configuration space which each function has, right? In PCIe, before it was 256. In PCIe, it was extended to 4096 bytes, okay, which is 4 KB, right?
Yeah.
So what is your question here?
And what is the difference between those two? That's what I was.
Those two means what? Those two.
In the header which was in the packet of my TLP, and as well as in type 0 and type 1.
So this is the register. Okay, this is the register. This is by default. If it is a if the function is a bridge, this value will be 1. Okay, first 7 bits will be 1. First 6 bits will be 1. I mean the value will, if you read it, will be 1. And just forget about last 7th bit, because that bit controls whether it's your device is multifunction or single function. So here it just tells that if it is device is 0, if it is a bridge, the value is going to be 1. If the value is if the function is endpoint, the 6 down to 0 of this field is going to be value 0. Now this decides whether your function is endpoint or bridge. Now you are getting confused with here. What is this value? So this says now that value is programmed in the function, right? If the TLP is coming, how would the switch or function would know whether this TLP is meant for me or not? If this is 0, if the first bit is 0, then it means that if a format type, if this bit is 0, this means that this is the type 0, right? This is always meant for some endpoint, right? Which endpoint? For that will be decided for bus number, function, device number, function number. Device number, function number already is defined, right? In the topology. Bus number, we just saw how the bus number assignment is happening, right? So now we know what is the bus number device. We know the bus number in the topology, right? So this bus number is 4. So this TLP will go on the bus number 4, right? It is meant for the bus number 4. So if it is 0, that means it is for the endpoint. If it is okay, if it is not captured in the slide, but okay, if it is 1, this is 1. If this is 1, if this bit is 1, then this is for type 1. That is, this transaction is meant for some bridge, right? And for which bridge, that we will get to know from the bus device number function. Does this answer your question?
Yeah, I got it. Thank you.
Okay.
Yeah, one more question. Actually, for bridge, what is the purpose of sending a like read and write request to the bridge? We usually send to the PCI, right? Endpoint or the memory, right? We send.
No, it's not like that. If you have a switch also has the 4 KB of configuration space, right?
Yes.
So while explaining the enumeration, I explained you in between, right? This okay, just a minute. Where is PPT? Okay. So I explained you this, right? Type 1 header is for what? It's for bridges, right? I'm explaining it again. It is for bridges, right? It's not. It is for the function which is not endpoint. This is for the function which is endpoint. Now, while the enumeration, you have to software is going to. I explained you when the enumeration is happening, when it is going depth first search, it is updating this bus subordinate bus number, secondary bus number, and primary bus number, right? It is going to do writes to this fields, right? So so that will be type 1, right? So in PCI topology, we can have at one port we can only attach one device only, right? We cannot attach lot of devices, correct? It's serial link. Let's say we have let's say we have 2 endpoints, 3 endpoints. So what we will do, we are going to use switch, right? And switch can have multiple ports, and we can hook our devices to the switch, right? So does this answer your question?
Yes. Like we can call like PCI endpoint to DRAM also. It's a type 0 only.
DRAM is not PCI. DRAM is a system memory. It's not type 0.
Like if I want to send transaction, then what it is then? Like from PCI endpoint to DRAM. If I send some memory write or read request.
Yeah, you can send it. So that we will be covering. So how it? So system memory is in system, we have system memory, let's say 2 to power 4 GB of system memory. So that range of memory will be mapped over here. Okay. What is the range of memory it is owning? You see? So if you have to initiate the address, the range of memory which this function is mapped to, not to any. If you update to any, it will be like decode error or something. Does this answer the question?
Yeah. What about IO also? It's the same thing.
IO is also same thing. So here IO, so in the legacy, the legacy endpoints only support the IO transaction. This native endpoint, like the latest PCI devices, they don't support IO transactions and all. But yes, IO is also kind of a memory map, and you will see that in future sessions I will be covering how they understand IO mapping, what is the range of IO mapping that which is mapped to a switch. So switch is nothing but just a routing, right? It's a router, right? So route the packet. If it's not meant for the switch, right? For switch, then it should know what are the addresses. The upstream port in the switch should know what are the range of the addresses living below me, right? I mean range of addresses that PCIe endpoints have, right? So,
yeah. Like what about PCI endpoint like P2P from one PCI endpoint to other PCI endpoint?
You cannot connect endpoint to endpoint. PCI endpoint is an endpoint, right? It is a function PF0, PF1, PF2. So the PF0 can be your camera, PF2 can be you can connect USB, DDR, or something, anything. Okay, that's how it is.
Hi Raj, suppose if my device is having more than 8 functions, suppose
You
10
cannot have more
functions.
than 8 functions. In Gen
Can you
3,
explain?
up till Gen 3, you cannot have more than 8 functions. But in Gen 5, Gen 6, I think it's up to 64 is supported.
Suppose if I'm trying to connect a device to Gen 3, which is having more than 8 functions, then how the Gen 3 would be dealing with that?
It cannot have more than 8 functions because BDF is implemented, such as BDF. F is the 3-bit function on 3-bit field. 111, it cannot go beyond 7, right?
No, but what I'm asking, you were saying it from the context of.
There is only 7 functions supported. How you will do 8 functions? That the device manufacturer has only given 7 functions. Then how you will do 8? Only 8 is given, right? This is coming from device manufacturer.
No, suppose consider the endpoint as camera. Okay, the camera is endpoint is a camera. Suppose. So the camera can have multiple functions, right? Like video recording, photo capturing, and
Camera,
like that.
okay. Functions, what here I am talking is camera is one electronic item which you are going to connect map to one physical function. Okay. Camera cannot have multiple functions. Camera is like your device, right? It is recording and sending the frames to the endpoint, right? And then it is processed, right? Similarly, you can have second function. You can connect it to some, let's say, USB. Okay. Or third, you can connect it to the monitor.
Can you repeat it one more time? Can you repeat it one more time?
Don't camera functions and the functions here, those are different things. Okay. Functions means here you are getting what I'm trying to say, right? Camera function is like camera is your kind of electrical equipment which is like capturing the data, I mean recording and sending the data frames to the function, and then from function, let's say camera, you have connected to camera and you want to you are recording and recording and the frames has to go in the DRAM, right? So what it is doing, it's reading and it's sending, it's recording and sending the frames to the endpoint function, right? And the endpoint function has the bar addresses, right? So it is going to send those frames to the system memory using the addresses which is mapped for this, function. You see the point?
Okay. Yeah.
Yeah. So don't get confused with the functionality of camera and the functions that I am talking. It is different. Okay. Functionality of camera is like you have a lot of functions, but the thing is, what at the end of the day, I mean, they are going to send some traffic to the device, right? Functions, right? They're any device you connect is going to send some data, right? And that data needs to go to the system where it can store it, right? Where it can be stored.
So actually, you were saying function one is camera, function two can be SSD, like that you were saying?
It can be,
Okay, I understand now. Got it.
because now function 2 has its own address range, right? It has
Yeah,
own 0 header and 254 KB of PCIe configuration space, right?
I got it. I got it now. Thank you.
And no two functions in the system memory can have same address range. This is illegal and not allowed.
Okay.
Hi Raj, I have a question. For the very first time, right, when you want to read the header type, what type of request is it the RC or host is going to give? Is it type 0 request or a type 1 request? The configuration request for the
You
very
want to
first time.
target. If you want to target bridge, it will be type 1. If you want to target endpoint, it will be type 0.
Now, to know whether it's a bridge or not, first we need to read the header type, right?
Means if the whatever the TLP is coming, I explained you there is one bit, right? Based on that, it is if it is meant for a bridge, it goes to the bridge. Every TLP will go through bridge and to the endpoint, right? If it is meant for endpoint, it will go to endpoint. If it is meant for the bridge, it goes for the bridge, and then we have in a TLP, we have the information bus number, device number, function number, right? So each bridge also has the VDF assigned, right, during the enumeration.
Yeah.
So it knows
yeah.
whether
So,
it's for me or not. If it's not, it just sends forward.
yeah, that I get that. I mean, for the very first time, right, when a device is connected, to know that whether it's a switch or the endpoint, you will have to
For
read
that, it
the
is header type is there, right? Header type.
yeah. To read that header type, are you is the PCIe or the host or root complex, is it going to send out a type 0 request or type 1 request? Because it doesn't know who is the device connected until it reads the header type, right?
Okay, it is going to do the configuration. Okay, I see your point.
See, by default, type is type 1 as far as my knowledge concerned. And moving forward, by comparing with the header type, when it reaches the device, it will change to type 0.
Okay, understand that. While okay, you have to understand this. While the configuration software is going to do the read and write, configuration software is not going to send actually okay, it is just going to instruct, right? Okay, that I need to check. Yeah, first time, because it does not knows what is the bridge type, so
Yeah.
it does not know what type of transaction it is. Okay,
Yeah, it is by
that is
default
the valid question. I need to check
type
that.
1 only.
Valid question. I don't know that, so I have to check that.
Okay.
Yeah, but I think even if it is whatever type it is, if it is it cannot, I what intuitively what I feel, it should not be of any type. It should be a generic read, a generic configuration read. Okay, which is because the if you see here the register number 3 up to 3 is same in both, right? So probably it would be reading the header type. Okay, generic, it will not be type 0 or type 1. Okay, and it will read this header type and then get to know whether it is type 0 or type 1. Okay, so this is, I mean, intuitively I can think of this, but yes, I need to check this
Okay.
first.
Thanks.
What is the type? Yeah. Okay, nice question. Okay, good question. Okay, no more questions.
You said during enumeration process, it will read device ID and vendor ID.
Device ID it reads, vendor ID it reads.
Okay, it is done through TLPs or any different process.
Yeah, it will be done through a config TLP.
Okay. Mm.
It will be done through config TLP, right? Because this is done, enumeration happens after the link is up, right? And the link is in L0, then the enumeration is done. During the link up, the enumeration is done, right? After the training sequence, this is done. Link training is done. Okay. Okay, I think there are no more questions for today. Anyone has questions? Otherwise, we will close the today's
One
meeting.
general question. Like in the PCI, right? Which layer has like verification will be more effort is required to verify this?
Idea.
Like which layer will
Physical
require
layer.
more time to do verification?
Physical layer.
Okay.
Raj,
Like one more thing, I am not getting the emails. I will share my mail ID to your number.
You're not getting the email.
Uh,
Okay. Since the participation was high, so were you part of the initial email sent to you?
no, I am not there. Like in the WhatsApp only, I got the from.
Okay. How we did it, like since initially since Zoom was not free, so we charged the participants some amount. Okay, it was 80 rupees, and those who paid, like there were I think 150 candidates who paid. Okay, for them we included, and the other slots were randomly filled. Okay, and like if you are part of that, then you would have been receiving email. Otherwise, if you are not part of that, you won't be receiving an email. So I don't know, like you got the first email or not. Okay, because
Hi
this
Raj.
time, yeah.
Actually, I am in that 100 people, but unfortunately, even I didn't receive any email communication from your side.
So can you send the message to Shraddha? You would
Sure,
have
sure.
messaged her right while paying the format which I mentioned. Just
Yeah, I did.
message her, she will include you in the list.
Sure, sure.
Yeah.
Thank you.
I too paid 80 rupees for supporting this Zoom and all.
If you have
But
paid, just message to Shraddha. She will include you the list, include you in the list. There may be some mess up have happened. I know some people are
uh,
not getting. So just message her, she will include you in the list while
in
sending it.
WhatsApp, right?
Yeah, on the WhatsApp.
Okay. Yeah. So what
Raj,
about video recordings will come? How
Yeah,
it
video
will
recording links are shared over there.
in mail only?
Yeah, in here the Zoom link will be there. You can see it.
Raj,
Thank you.
Hey, Raj, there is just I have a fundamental question, like very small confusion. And like the function is specific to the configuration is specific function only, right?
What?
Configuration
It is for
space.
functions.
Yeah.
Okay, but function can be endpoint or it can be a bridge.
Bridge, okay. So like for instance, you can go function is 3 bits, 8 function. Yeah, it's 8 pens. But BDF concept, 8 function can be possible. So for instance, one device, yeah, 8 functions are possible per a device.
Yes, 8 functions are possible in Gen 3. Yeah.
Sure, if it can be a multifunction device like in implementation space, all 8 can be configuration, having the configuration space of 4
Yes,
KB.
everyone has a configuration space. So if 4 KB on a bus, we can have 256 bus, right? We can have 32 device, and each device can have 8 functions, and 8 functions and 8 functions can each function can have 4 KB of address space, right? So if you calculate it total, it will come 256 MB, okay, for each bus.
Okay.
And
Oh.
in PCI devices, instead of actually going ahead and reading the addresses, in the function, we have mapped this in the system memory, so that we are directly able to read it from memory instead of doing the old read, right, where we were using 2 cycles and all.
Okay. That configured instead of doing config memory read, it can be done.
Yeah, it's kind of mapped in the memory, but we say it's a configuration space. You can only read 1 DWORD at a time.
Okay. Okay. Thanks, Raj.
Raj, the device also will have the configuration space?
Which have?
Device.
Device has the functions, right? And function
Yeah, device has the functions, and each function has a 4 KB configuration space. And device also will have the configuration space or not?
No, device consists of the functions.
Okay,
A list
that's
of
it.
function consists of device.
But device has some register space, right? To configure these bus numbers and
this is not in the device, that is in the so this is not, it is a function, it is in the function. Okay, when I'm saying this, Where is the? This is the PPT, right? Okay. See, when I am saying this, this is actually nothing but. Okay. This is a device. Okay, and this has one function. This is what does it mean? Okay, device. This is the bridge, but this also can have up to 8 functions. Okay.
Can you repeat?
This is a bridge.
Yes.
Internally, to the enumeration software hasn't changed right from the PCI side.
Okay.
And to the software internally, it sees them as a bridge. Okay.
Okay.
And on this bridge, we can have up to 32 devices, right?
Yes.
So, and devices means what? It has functions, right?
Yes.
So we have the function over there. Each function has the configuration space. Why it is done? Now here the PCI is P2P link, right? You can only hook only one device here. You cannot hook 10 devices. Okay. But in the
Yes.
PCI, this was not the case. You can hook up to 32 devices. Here you can have only one device, and one device can have a number eight functions. Or you can use bridge, what we call a switch, and then you can have fan it further. Okay, but on every P2P link, the device number will always be 0.
Okay.
Okay, it cannot be more than 1 because it's point to point. We are sending the data serially. I explained, I think, yesterday's lecture how the data is flowing and all, right?
Yeah.
Okay.
Raj,
Yeah,
adding to the same question, but here a bridge, right? A primary upstream bus and secondary two, like bus taking left one, upstream bus 1 and downstream bus 3, bus 4. So 3 P2Ps, each one have it's like a 3 punks. It's a device, it's a bridge of with 3
No, it's not a
functions.
3 bus. It's a bus number 2. Primary
Okay.
means what is the bus
Okay.
above this 2? What is the bus? Secondary means what is the bus below this? And subordinate bus number, I explained you how the subordinate bus number is assigned, right?
Okay.
It starts with the 255, and when the depth first search traverses back, it knows what is the maximum bus value here. So the subordinate bus number is separated from 255 to 3.
It's a function of type is type 1. So again, it is a
Type
single
1, right?
function.
It's the bridge, right?
Single function of 3 functions here.
What?
This bridge having a 3 functions like upstream 1 and downstream 2.
I didn't get you. Didn't get your question.
This one actually the same bits what we are cursor pointing. So this is a PCI bits having a 3 bits also like is a device, right?
It is no. This is full. This full is a device. Okay.
Yeah. How many functions here? This one.
Okay. This is okay. This is PCI. Yes. This is, you can say this is a PCI device. Yes. You can consider it as a PCI device. And here it has only one function.
So like after 2 downstream, like bus 1 upstream, 3 functions altogether. This bits.
Only one function, right? Only one function. So this is second device.
Okay. Okay. Okay.
So
Upstream
this is
also
a bus.
one.
If you think from the PCI point of view, this is a bus, right?
Okay. Okay. Got it.
In the
Sorry.
PCI architecture, how many devices can we hook to a bus? 32 devices, right?
Yes. Got it. I confusion.
This is second device. Similarly, software is going to scan for 2, 0,
Yeah.
device 0, device 1, device 2, device 3, up to 31, but it doesn't find, right?
Yes,
it is going
exactly.
to the vendor ID, and it says because address is mapped in the memory space, right? So it reads the address, but it says that vendor ID is invalid, so it goes back.
Yeah,
So
got it. Yeah. I got confusion differently. Like I'm thinking like not all the 3 function bus. Your bus is varying, right? So 3 independent devices.
This for this device 0 function 0. This is device 1 function 0.
Function 0.
Okay.
And upstream also one like device.
This is also device 0.
Function 1, bus 1, function 1, function 0.
Yeah. Because this is also a device, right? So this is a device 0, function 0, but no, sorry. This will be a device 0, I guess.
Okay.
This device 1, this will be device 2, because see, this is a PCI, it is PCI bus, right?
Yes.
And this bus, it can be connected to up to 32 devices, right? So this is kind of one device.
Okay. 2 devices independent and a single function you can take.
Yes.
So
That's
it's,
what
hierarchy is
it
important.
should be like that.
Yes, thank you.
Actually, I have one question regarding this same one, the enumeration. So primary bus numbering is fine, but how the secondary numbering will happen actually?
Next bus.
Yeah, for the next bus.
If you have 2, you will come 3, right? But when you are coming here, primary 2, bus number 3 is already used, right? So it will assign bus number 4.
Okay.
So it is whatever the bus number is used, next bus number it will be using, right?
Okay.
If you see here, bus 6, it is assigning secondary as 9 because up till 8 is already used, right?
Okay.
So
Based on the subordinate bus number +1.
No, subordinate bus number I explained, right, how it is working. Subordinate bus number, when you traverse back the 255, initially it will be 255, and then
Yes.
since if I just say take this example, this is bus number 3, it comes here and sees it is the end point.
So
Initially when it comes here, it is going to update this with 255. Okay.
Yeah.
Now when it goes back, it says what is the maximum bus number below this. It is 4, right? So it's going to update 4. Sorry, it's going to update 3. Okay. So it starts with 255. Here also you are seeing 4, but initially when configuration software starts, it starts with 255, traverses it and comes back over here, right? And now it knows what is the maximum bus number below this is leaving. It is
Yes.
leaving 4, right? So it is going to update 255 to 4.
Yes. After updating 4, in the next
You will go
iteration
to this device.
on device 1,
Device
yeah. So it will be updating the after 4 available is 5, right? So it will be updating 5 in that way, right?
Yes. Till here 4 is done, so it will update 5. But initially subordinate bus number will be 255, goes through, traverses, and then comes back, right? So now it knows what is the maximum bus number, so it puts 9 over here.
Yeah, clear. Thank you.
Okay.
Can we get the PPT of above?
PPT is going, right? Shraddha will. But PPT is just for, I mean, okay, to learn for PPT is just for reference for we have created for all the just for presentation, but it's better to go through the spec, okay? I mean,
Well, sharing each day's link, Zoom link. If it shares, it will be like easy for understanding.
just a PPT, yeah. Okay.
If you share, it will be good. Okay, thank you.
Okay. Thank you, guys. I think we are done for today. Thank you for joining. Bye bye. Take care.
Thank you. Stop recording, Raj.
Thank you.